everything we do in science is a metaphor. When we show a picture, we've chosen the colors we're going to show it. It doesn't really look like that. We've done a lot of preparation. It's just everything is a metaphor of what we're really studying. I like to experiment with metaphors and try different things, hoping that we'll find one that's a better description. There's a statistician who once said that all models are wrong, but some models are useful. And so if you go in and you say, okay, the model I have for this, I know is wrong. Eventually it's going to be disproven. Can I just find one that's good? When we started working on tolerance and on immune memory in infections, we found not everyone liked the idea. And I showed up at one meeting and they had a debate on whether the work was true. And the way I internalized it, I thought, well, the problem must be that I'm not telling the story properly. So I went back and I started doing stop motion animation with my daughter's Playmobil to explain what was going on in a way that was, it explained the story too, and it was a little bit funny, and it worked really well. People understood what was going on better than they had before. So this is a malaria clock. Instead of telling time, this tells you where you are in the course of an infection. So it shows the real data of a mouse infected with malaria and what happens over the whole course of a 24-hour infection. The clock face is meant to show health, sickness, and recovery. So as you go around, you move through the different parts of the disease. The top here, this is a wheel that shows what's happening with the parasite growth, which happens on a daily cycle. I made it as a joint project with Rebecca Gelman when she was a graduate student in my lab for a meeting at the Santa Fe Institute, where I was going to have to talk to just a broad group of smart people who were interested in ways of portraying time. We thought the best metaphor for that would be to make something that used a clock as a metaphor. So I think we're fixed to showing things in 2 dimensions because the medium we use is the paper, and it either is something that gets printed out or we look at it on our screen. But we have really great computers now, and you could look at things in 3 dimensions or higher dimensions, but we still tend to just make flat things. So I had some difficult multi-dimensional things that I wanted to show, which is why I started making physical models of it. So what this shows is where you are at each step of the infection over 21 days of a Plasmodium infection. And the data for 9 different things that go up and down in the circulation are plotted each on an individual cam. So as you go around here, you can see this one has a peak. That happens to be gamma delta T cells. They come up at the end of the infection. And so what happens as you crank it is you can see the shape of the infection in a way that I haven't found a better way of showing otherwise. So it looks like you've dropped something into the center of a pool and you get these radiating waves. And so what happens when you show up at the clinic, you're about here, where the early things have turned on and turned off, and the later things haven't turned on yet, and you're in the middle of a wave. And so what we're hoping is that by looking at the shape of this wave, we'll be able to figure out how you're doing, how you did in the past, and what's going to happen in the future. What's going on? Let me take a look at it. I find it feeds back, so when I make these models, it helps me understand the problem better. And it's something you don't easily get to when you're just drawing it on paper. You have to think about what's really physically happening. And I find the same thing when I make my models, that I get to a point where I realize I'm making some guesses about what's happening with the biology, and I have to turn it into something physical, and that can send me back to do experiments about that. You know, we've got some hard problems. The regular ways are not solving it. If we try thinking about it using metaphors from, clock making or astronomy or dance, Is that going to help us solve problems better? So we'll see.